Next question is nothing different, but it requires one more step. So what does it say? The thickness of a part is to have an upper specification of 0.925 and a lower specification of 0.916 millimeters. Yeah, the specifications are defined by the design engineer, right? The average of the process is currently 0.917, standard deviation is 0.005. Determine the percentage of product above and below the specification limits. So that's a good question. So we have mean value of 0.917. We have standard deviation of 0.05. And we have x1 value of specification limits 0.925, x2, no, I want to switch those numbers, 0.916. I want the smaller number to be my x1 and the bigger number specification limit to my x2, because x1 is going to be on the left side of my mean and x2 is going to be on the right side, but you can keep them x2, x1, it doesn't really matter. All right, so those are our critical values. And let's do the graphical representation on a normal distribution. Oh my God, my normal distributions are always not so symmetrical because of the pen that I'm using on that screen. Anyway, so mean value 0.917, standard deviation 0.05, and we have one value very close to the mean value here, 0.916, and we have another value a little bit far away from our mean value, 0.925. And the question is determine the percentage of product above and below the specification limit. So that's a critical question. It means that what is the percentage of unacceptable parts? So if we want to represent those areas below and above the specification limits, this is my x1 and this is my x2. x1, x2. So this really doesn't help me a lot. What I need to do is I need to calculate the standard normal distribution. When I make that transformation, my mean is going to be 0, standard deviation will be 1, and this will be my z1, and this will be my z2. And again, I'm going to calculate these areas. All right, let's go ahead and calculate those z1 and z2 values. Our formula is x minus mean divided by standard deviation. And let's plug the numbers for z1. What is the x1 value? 0.916. 0.916 minus, what is the mean? 0.917 divided by 0.005. How about z2? z2 is 0.925 minus 0.917 divided by 0.05. Oops, 0.005. All right, from here, if we do the math, z1 value is going to be negative 0.2, and Z2 value is going to be 1.6, right? 0.2, 1.6. Now let's find the area to the left of this value first. Let's go to Z table. What was my value? 0.2, negative 0.2. So here I have 0.2, right? Negative 0.2 from the first column. And for the decimal, second decimal, I'm going to use the 0.00 value. And at their intersection, here, your area, 0.4207. This is the area to the left of our first Z value, which is Z1. This is mu, this is Z1, this is Z2. This area is 0.42. Actually, I placed, yeah, it should be somewhere here. Proportionally, yeah. This area is 0.4207, if I'm not mistaken. Yes. So our first area is calculated. Now I need to find what percentage or what is the area on this end to the right side of my second specification value. How do I calculate it? Because my table is, the problem with my table is it's a left reading table. It's not calculating the area on the right side of a certain value. So what I need to do is subtract it. First, I'm going to calculate or find the area on this side up to this point and subtract it from 1, because the absolute value under that curve is 1, and it will give me the area in this small region. All right. So let's go to the positive numbers, because our second Z value is 1.6. The second page of the Z tables is here, 1.6 on the first column. And here again, I'm going to use the 0.00 decimals, and that area is 0.9452. 0.9452. As you see, it is the area on the left side again. So let's go back. 0.9452 is the area from start to that critical Z2 value, all the area. I don't want to show it on the graph because it's going to make it really crowded. So let's calculate this area. How do we calculate it? 1 minus 0.9452 is going to be the absolute value of that area. And what is that area? 0.0548. All right. This is the area on the right side. Now, this is the area on the left side of our critical values of Z1 and Z2. And all we have to do is now add them up and multiply by 100 to calculate the percentage. So 0.4207 and 0.0548. And this is going to be 0.4755. Let's multiply by 100. So 47%, 47.55% of all the parts are above and below the specification limits. So this area represent that 47 point something, 47.55% of all the parts are either below the specification limit or above the specification limit.